All right, so we're going to look at some of the trickier cases when using the law of sines. All right. So in this example, we're given side A is 15 units long, side B is 25, and angle A is 47. So we're gonna try to solve for angle B. All right. This is going to end up being impossible, but you'll see why. All right. So here's what we got. We're going to have we got it already set up. Nice. I need to multiply by 25. So I get sine of 47 times 25. And then I'm going to divide that by 15. Okay? So what I get here is that 1.21 is equal to the sine of b. And this is impossible. All right? Remember, the sine function kind of oscillates between 1 and -1 over and over. It never reaches 1.21 units. So when I do the inverse sine to this thing, inverse sine of my last answer, I get an error. All right, so it's an impossible situation. And I'm going to try to explain why it's actually impossible. We'll see. So here I'm trying to draw a triangle that makes sense for this. I've got angle A is 47 degrees. I've already got that. I don't know how far out this thing's going to go yet. Turns out it won't matter. I know that this angle right here is constant. I cannot rotate that. I can't close that angle. I can't expand that angle. That is a fixed part of the problem. Side length B, which is going to be connected to side A. All right, side B is 25 units this way. And A, because it has to be side A, because it has to be opposite that 47 degree angle, has to be right here. Well, if this is 25 and this is 15, like this one's shorter than this one, there's no way that this little thing, no matter how you rotate this angle, no matter how you twist it or whatever, it's never going to be able to make a full triangle down here. It's not going to reach. I would have to close this angle a bit in order for it to be connected, and I can't do that. All right. So hopefully that's an explanation for why this is an impossible situation. All right, let's look at another one here. For this one, we've got side length A is 25 and angle A is 42. Side length B is 10, and we're solving for angle B again. So let's start it up. We're going to multiply by 10. So it's going to be 10 times the sine of 42. And then we're going to divide that by 25. Okay. And then I'm going to take the inverse sine. So let me do this real quick. Sine of B is equal to about 0.2676. I'm going to take the inverse sine here. Inverse sine of my last answer. And I got 15.5 degrees. So that means B is equal to 15.5 degrees. And this is a true thing. It's a true statement, all right? The problem is that your calculator only found one answer for this equation. There's actually going to be two answers. There's two different angles that you can take the sine of to get 0.26. You could do the sine of a 15 degree angle, and it's going to give you that. So if I think back on my little unit circle definition, so right here, if I look at 15 degrees, all right, 15 degrees, what the calculator is saying is that this up and down distance is 0.26, is 0.2676. But that height, for it to have a height of 0.2676, also occurs way over here, right? At whatever angle this is, right? At whatever angle that is. So there's two places where this is going to happen. And to find it, what you do is you just do 180 degrees minus this one, right? And that's going to give you that angle. So 180 minus 15.5. Let's see. 180 minus 15.5. All right, I get that. 164.5. And if I take the sine of that, I'm going to get that 0.267 again. So that's what I was trying to say is there's two answers for B that will give us 0.2676. But this one is actually impossible given our situation. All right, so the reason that this is impossible is because I can't have 164 degrees as an angle in my triangle and have a 42-degree angle in there, because that's going to put me over 180 degrees. All right. So in this particular situation, there's only one possible triangle that's going to make sense. All right. Angle, let me see if I can get this. Angle A is 42. So I drew that, and that's fixed. Angle B is 10 units long. So I've got that fixed. Side length A is 25 units long. So I drew that out, 25 units. We were trying to find this angle B. That's what we were after. And I think it's pretty obvious, from the picture that angle B has to be an acute angle. All right. That's why it was 15.5. All right. It was going to be impossible to get another obtuse angle here, because I already had an obtuse angle showing up over here. All right. But there's that. The next one, we're going to get into the actual tricky case, the one that's really tricky. That's the ambiguous case.